Hello viewers, welcome back to video tutorial on AgentGrid. In this series of video tutorials, we were explaining different agentic patterns using our open source AgentGrid SDK. So in our previous videos, we have covered patterns like sequential pattern, conditional sequence pattern, parallel pattern, router pattern, orchestrator pattern, human in loop pattern. And in this video tutorial, we'll be discussing the critic reflection pattern. So let's start the tutorial critic reflection pattern with open source AgentGrid SDK. So as generally we'll take a one special example for explaining this pattern. So in this current agent pattern, we will be using software architecture debate, where software agent will be proposing or designing an proposes a design, whereas a senior architect agent which provides a critical feedback to the design, and it will also score the designs, and based on that when a quality threshold is met, the architecture will be finalized. So that kind of architecture debate discussion will happen in this particular critic reflection agentic pipeline. So a case study, a software architect debate critic reflection. So a critic reflection pattern involves one agent, we call the first agent a reflector, generating and content, and another agent which is a critic, we call, which will evaluate the generated content. And the reflector then incorporates the feedback to improve the output of subsequent output in subsequent rounds based on the feedback it receives from the critic agent. So let's say the architecture debate pipeline, we have a propose which is nothing but a software agent. It analyzes the user requirement and proposes a set of technical components for the user requirement. And then we have a senior architect agent which takes the output of the software agent, and initially it parses the software proposed by the software agent, and passes and proposals into individual components for granular evaluation. And the critic, the senior architect agent, which acts like a critic, evaluates each component it has passed using a mathematical scrutiny and a crazy probing. We will tell what is crazy probing in the later stage. For any failure mode analysis, like whatever the component it has designed, whether it is good or bad, it will try to give some feedback to the software agent. And score and feedback. So critic assigns a satisfaction score. If the score is less than 95, it provides a actionable feedback, so that again the software agent will pick it. The reflector, the software agent, receives the feedback and provides an updated or a self-contained technical specification, or defends the original design. Let's say the score is not good, it provides a feedback. Upon that feedback, either it has to design a new component, or it has to defend its original design, why that component is required. So that's what the software agent will do. Again, this loop can continue like 3 to 4 rounds, and at the end, since we have put some 3 rounds as a hard threshold, after 3 rounds, senior architect will take that component as finalized one, and it will at the end, once all the components are finalized, then the senior architect will synthesize the full report for the user. So the senior architect only will design the full report, not the software agent. Software agent is for a debate purpose only. So it will generate the initial architecture, gives the components to senior architect. Senior architect breaks down whole architecture into components, gives the feedback. Again, this loop continues. At the end, once all the components are finalized, the final draft will be given as an output to the user. So we have only 2 agents here: software agent, which acts like a reflector, and a senior architect, which acts like a critic. So these are the 2 code files. Generates initial plan, iteratively refines them based on the critic, evaluates plans using rigorous technical standards, and assign approval scores. So let us see the code base. So this is the code for a software agent. So it has a 2 DSPy signatures. One is for proposing the software architect. So you are a software architect generator. Your goal is to design a complete high-level software architecture based on the user's requirement. Propose a set of discrete components that will make up the system. For each component, provide a high-level technical description. So it takes the user input, generates a high-level architecture, and gives a proposes or gives a high level component technical description as well. So input is a user request and output is a reasoning and a architectural plan. So these two outputs are expected from this particular DSP signature. It has one other signature as well. This signature will be used during the evaluation phase. So this is during the first initial architecture design, and this will be used for a component evaluation, meaning like whenever they are debating, it will use this particular signature. So in this signature, you are a software architect generator currently in a refinement mode. So you will work on the one component at a time and directed by the senior architect. So here the critical instructions are there. So no procrastination. You must implement all architectural changes immediately in the component details. Never say I will add or in the next version, something like that. So you have to take that into effect immediately. Technical assertiveness. Your output must be professional technical specification. Avoid conversational filters like I acknowledge or I thank or something like that. It should not be using those words. Concrete solutions. Provide specific technical answers. Do not say I will use a distributed database. Like don't use the general terms. It has to be a component wise. So I will implement a 3-node HA cluster using a Postgres SQL, something like that. It should not say. It should give a complete proper details. Quantitative precisions, if requires, you have to give a quantitative data as well, like estimated load, RAM, disk IO, network bandwidth, etc. Some calculations are required, right? It has to do that calculation. It has to provide those details. Standalone spec. Component details must always be complete. Self-contained technical specification of the current best version of this component. So evolve or define based on the feedback. Either you have to evolve it or you have to defend the design that you have done or the component that you have chosen. No echo. Never repeat the same content again and again and again, because since you are in a feedback loop, right? So there is a tendency that it can regenerate again the same content. So inputs are user request, finalized components. So for whatever the components are finalized, right, that details are required here. And current component, what is the current component that it has to it is in a discussion mode currently. Component history. So for this component, are there any history going on? Like say, since we are talking maximum of 3 times, so is it already being evaluated once? If so, what all are the feedbacks? So it requires certain sort of histories, right? So for that we are giving a component history and the feedback that it has got from the senior architect. If for the first time this feedback will not be there, then maybe it is empty, or if feedback is available, it will be given here. So using all this, it has to provide us a reasoning and a component details. So why it has chosen, what is the internal technical trade-offs, why it chose A over B. So that kind of details, reasonings will be available here, and a completely updated technical specification for this component. No conversational text is expected at this particular output. So a software agent module, we are initializing 2 chain of thoughts here. One is for the first signature for architecture design, and second is a conversational for a component discussion. So we call it as initial generator and a component refiner. So in its forward function, we are checking whether current component name is the initial architecture, overall architecture. If it is initial overall architecture, then we'll be using the first DSP chain of thought. Or if it is not an initial overall architecture, the current component is not an initial overall architecture, then it will do the component refiner. Means it will use the second DSP signature. So as you can see here, this chain of thought, the first signature is taken by system prompt, which we will be registering for this particular agent, and the second we are directly taking it from this particular doc string only. So we are not doing a with instructions. So doc string only is taken as a system message or a system prompt. So the payload processor, which will basically parse the given input. So the input is the agent task class. So in that, whatever the inputs are there, that will be broken down and it will be returned to the code. So where user request is required. So basically these inputs are nothing but either it will contain this or it will contain these items. So user request, current component name, component history, finalized components, feedback. These details is what so far we have seen here. And again, certain other things like model name, session ID, round count component, how many counts are over. So that kind of details are for this component, how many counts are over. It is overall count. So all those details are required here. So will be passed here and given. given for the whenever you call a prepared payload function. So this is a model context manager which will manage the context for a DSPy inference. And this is the main class, software agent. Here we are using agents config.yaml. So the reason for this is we are not hard coded who is the next agent, so all those details will be available in this config.yaml file, and we are initializing those classes that we have seen in the above, and we are using a his client as well, so human in loop service client. So this client is required not for taking any input from the user, but we will use this client just to show what communication is going on between the both of the agents. So whenever they are about to talk to the next agent, right, so they will send the data to my his dashboard, and that will be shown you as a time graph, like what is the first communication, second communication. So I will show it in a Streamlit app. So there is no need of muxer, so let's directly jump into the onData class, sorry, onData function. As soon as input is received, we'll call the prepare inputs function, which will break down that task to this kind of content, and then we'll call a self executor worker where we'll send a user request, finalize components, current component name, component history, feedback. So feedback will be empty during the initial the component current component name will be the initial component. So if it is for the first time, the current component name will be initial overall architecture. For second time onwards, it will not be there. So if this is the current component name is in initial overall architecture, then it will go for the first signature. If not, it will go for the discussion mode, second signature. So that's what this executor worker will do, and it will return the result. And in that result, we are trying to parse this whether we are checking whether component details are there or not, architecture plan is present or not. If so, then we'll take those if architecture plan is present or a component details is present. So from that we will take architecture plan, and that is the proposed architecture. So that we will send to his client. Here we are using only submit, not submit and wait. If you do submit and wait, some feedback has to come from the client as well, so his client as well, the user. So but here we are using simply submit, so I'm not expecting any user, it doesn't have to do anything. We are just submitting it, and we are moving on. So there is in the exception also I'm just doing a pass. So his client is used just to show the communication, the content. So what it shows is the message here. The message is nothing but it will show you the round count, what is the current component name, what is the proposed architecture, and the reasoning also. So that will be printed in the his client. So next, once it is so the data is sent to the his client, then it will do a call senior architecture agent, because the next agent is a senior architect. It will call the delegate task function, where you will send everything like task, proposed architecture, user request, current component name. So current component name initially it will be nothing, so empty only. So round count component, etc, all those details will be sent in the delegate task. So in the delegate task, it will just format the payload, and it will send to the next agent, which is nothing but the senior architect agent, either in P2P or in a direct submission. So there's nothing much in this delegate task. And also this function, we have done some in our execute worker, we have done some attempts here, like 3 times, maximum count is 3 times. I have hard coded right now, but maximum this while loop has to run 3 times only. After that it has to break, and it has to whatever the final output was there, right, in the previous round, that will be considered as the final decided content, technical content of that particular component. So it will be looped 3 times. If the content is not good, or a number of characters are less, or it is not clearly like the final component is not complete, meaning the agent has generated only half component because of token issues or something like that, right? So again we are trying to do a rerun, retry as well. So basically 3 times it will try to talk to the it will try to do a inference. Then if attempt is greater than max attempt, it will try to less than, it will try to sleep again, and it will try to rerun it, and at the end it will break. So why is that, why we have added this is because sometimes we have seen it will not generate the full content, it would have generated half content because of our number of max tokens. So for time being, I have increased the max tokens to 4K for the software agent. Whereas for a senior architect agent, I have kept max tokens to 10,240. The reason for that is it has to finalize, or it has to synthesize the data for once all components are finalized, the final synthesis of architecture or report generation will be done by the senior architect. So it might have too much of tokens to be generated. So that's why we are giving a higher token size, like 10k token size for a senior architect agent. Whereas for a software agent, it is like just like a 4k tokens. So this is about the software agent. So next, let's go to the second agent, which is a senior architect agent. So here again there are several components, the signatures. The first is component parser signature. So parse the software architecture proposal into a discrete named component and their descriptions. Output must be a valid JSON dictionary where keys are component names and values are detailed description. So whenever the first time the architecture is received right from the software agent, it has to parse. So for parsing, this is the signature that it is using. So propose architecture as an input and component map JSON as a output, a JSON dictionary, component name colon description as the output. So next, component evaluator signature. So this is for during the evaluation phase. So you are a senior software architect, solution architect, evaluate a specific component of the software architect proposed by the software agent. Quantitative scrutiny, mathematically you have to evaluate the proposed component. Is the load prediction realistic for the user request? Are RAM, CPU, disk estimates are sufficient or overkill? Will the proposed architecture meet the required network bandwidth, latency targets, etc. or not? So creative probing is also required, meaning don't just check the requirement compliance, you just have to ask some crazy questions as well. So let's say you have 3 nodes. What if one node goes down, how it will behave? Let's say if disk space suddenly goes down or up, what happens to this node? So some such kind of crazy questions also we are asking it to ask, so that it will software agent can think about those as well, the crazy questions. Your goal is to break the design into ensure a bulletproof, assign a satisfaction score, and only approve if the description is technically flawless and satisfaction score is more than 95. So input is user request, finalized component names, current component name. Finalized component name is list of all the components that has been finalized till now. Let's say you have 10 components, 5 components are finalized, and that details has to be available in this particular finalized component names. And this is the 6th component name, and the 6th component details is required here. So it will give like a boolean whether it's is approved or not, and satisfaction score, and a feedback, and a reasoning. So this feedback and reasoning will be sent back to the software agent. And next is the final synthesis, meaning a final report generation. Again, we have a signature. Consolidate all the finalized components into a complete professional architecture report. Describe each component's role satisfying user's request. So here user request will come, finalized component will come, and finalized final architecture report has to be the output from this particular signature. So we have a module. Since we have 3 signatures, I'm creating 3 DSPy chain of thought objects. One is parser, one is evaluator, one is synthesizer. For parser and synthesizer, I'm using a predict because it just requires a prediction only, no need of reasoning at all. So whereas for evaluator, I require a reasoning component as well. So that's why we are using a chain of thought. So for parsing, I have not kept a forward function. Instead of that, I have kept some 3 functions here. Forward parse component that will be used by the parser, evaluate component that will be used by the evaluator, and synthesizer we will use the synthesize final. So these are the 3 functions that I'll be using wherever I require a parsing, wherever I require evaluation, I'll use this function, wherever I want to synthesize, I'll use this function. And this payload is payload breaker. Basically, it breaks the agent task into a different inputs, and a model context for managing the context of the agent. So here is a debate state manager. Basically, we'll be writing the state of each components in one session file. So finalize session dot finalize underscore session ID, and debate history session ID, and pending session ID, and a round count session ID.json. So there are 4 JSON files that will be maintaining it inside the agent pod. So this is according to the session ID. So whenever a session ID changes, let's say you are talking, 2 users are talking, so they will have a different session ID. A separate JSON files will be created for them. And what this will maintain is instead of maintaining the context in a big dictionary, so we are just dumping it into a JSON file, so that even if something goes wrong, so it can pick up from those files. So finalized will contain the finalized content, pending will contain the pending component, still not over, they are still pending. Let's say 5 components are over, it will be in finalized, and five components are not over, it will be in a pending. So debate history, if one component is history is going on, debate is going on, so its history will be available, like what software agent told and what architect agent has debated or given a feedback, reasoning, and all those will be stored in a debate history. And round count, it's for how many rounds are over for one particular component, so that kind of details will be available in this particular JSON file. So, and also you have a sub file, like it is just for loading, and we have a saving state, saving all those details in the JSON files, and cleaning up, basically removing those files from the agent pod. So this is our actual class. So the rest remains, everything remains same. We have again here his client, basically to dump the output into the our his client, the Streamlit app. And let's go to the on data function. So in on data function, so we are first breaking the input to a whatever the agent task input comes, right? So we are just breaking it down. So we get the let's see this function, because this function has several other tasks as well. So prepare input. So what it does is, whenever an input comes, agent task comes, it will break it down, and from that it will take the user request and propose text from that. And then if they are empty or something like that, then it will say it is an invalid content. If it is not, it will raise a value error. If it is not, if it is contents are proper, then it will try to check the state manager load state. What it basically is, what it does is, whatever the JSON file so far has been stored or something like that, right? So it will try to load it, so that we'll get what all components are finalized, what all components are pending, what all components, what is the debate history, how many counts are gone for each component. So I need that details also for my further processing. So I'll do a load state action, so that it loads up all those content. All this dictionary will be loaded up from this JSON files, and those will be sent as a those will be returned from this particular function. So initial round, so if round count is less than or equal to 1, it means it is the first time it came here. So we have to do a parser call, it will be doing here. So self execute parser. So initial round, parsing architecture into components. So it will, this execute parser will break down the whole architecture into components, and that component map will be here. And then we are creating a pending key. That pending will be later on used for saving the state here, pending. And also finalized. So finalized also we are getting it from this particular, if at all any finalized component is there, right? So we will get it, or else it will then initially it will be an empty content, so nothing is finalized, so this will be empty. So pending, we have pending variable we have updated here, and a round count. So what is the count, what is the component, and in which round it is, so that details will be available in this particular variable. So if the round count is greater than 1, it means already the it is not an initial, it is a it's in a discussion phase now. So so what I do is I just update this pending zeros details. So the recent pending details I am just updating to a proposed text, if proposed text is there. Proposed text is nothing but it can be a text from the agent software agent. So the proposed text, what you can see here is, it is a proposed text here. So it is coming from the agent task. This agent task is the input, which is nothing but from the software agent. So from software agent, whatever it has got, that will be updated into the current component. So which is nothing but pending 0 of details, and that will be again used in the that will be the pending will be returned here, right? So basically a software agent's output will be updated in the pending, and it will be returned from this particular function. So next, so yeah, we have prepared the inputs, and now if pending is not empty, so yes, once the architecture is passed, pending is not empty, so it is having some content, because if 10 components are there, pending will have 10 keys, 10 list of 10 items, and since it is not, so it will not go to this. So only when pending is empty, it means all the components are finalized, then only it will go for a synthesize. If not, it will not go for a synthesize. So in the synthesizing, I'll explain later. So So now pending 0, which is the current component, and I'm taking the component name and I'm calling the evaluator1 function. So in the evaluator1, we'll send a user request, more current component finalized and round count. Let us see what evaluator1 will do. So evaluate one function, it will try to so we have iterations, display iterations, some numbers for displaying. So evaluating, it will log this evaluating, which component it is evaluating and what is the round of it. It will just log it, and then we are calling a execute evaluator function, which is what the second DSPy chain of thought. So evaluator, right? So it will use that evaluator. So yeah, so execute evaluator it will do. Then raw score, it will try to get the raw score from it, because it has the LLM has now analyzed the component that it has got from the software agent. It has evaluated it, it has calculated the raw score, and then we are trying to get the int value out of it, because we require something in 80, in terms of 0 to 100 we want. So it is trying to convert that to a int value, and then we are creating one message. This message is for passing on to his client. So evaluating, this is the iteration, this is the score, whether it's approved or not. If score is greater than 95, it is approved, or else it needs a refinement and reasoning for that. So that will be pushed to his client. So this is the job of evaluate one. So it evaluates it, and whatever the evaluation results and scores are there, right, it will be returned from this particular function after doing a his client submit. So his client submit is an asynchronous. So next, so evaluate one is done. So we got evaluation result and the score. So based on that, we are initializing the debate history, and we are dumping the content that is required for the debate history. And we are trying to check whether if the score is greater than 95, then approved is true. And also we are trying to get the iteration, how much iteration it's going on, and whether force approval is done or not. Force approval is done only when it has approved, the score is less than 95 and more than 3 rounds are over, then only the force approval will be true. So yeah, if he is approved and iteration count is greater than 3, then he is approved will be made true, and force approval also made true. So if he is approved, then it will pop that from one item from the pending, because that is approved, right? So it is not required in the pending. And or if force approval is done, so we are just mentioning like it is a reasoning. So what is the last score and reasoning, we are mentioning it in the current component details, and that we are dumping into a finalized one. And this finalized one will the current state, what is the finalized content and the pending content, right? So that will be updated in the JSON file using save state function. So if it is not approved, then it will go for a feedback. So in the feedback, again, you have a response text here, critic of a previous proposal. What is its score? What's its reasoning? What's its feedback? All those details are present here, and we are dumping it in a JSON file. And also we are calling a function send to software agent function, and in that function we'll be basically passing on these informations to software agent. So before sending to software agent, send to software agent, we are doing an his as well. So his client also we are doing a submit, meaning whenever both the agents are talking to each other, just before talking they will dump their content to his client, so that we can see it in our code, our Streamlit tab. So yeah, that's it about this code. So let us see how let's see this in action right now. So we have all.bash. I've already run it, so it has all the pods running for agents, and I have to run a Streamlit app. So right now the Streamlit app is not running, so let me run it in a background. So bash -bg will take it in, make sure it runs in background. So it has run. Let me just refresh it. Yes, this is the his dashboard architecture debater. So let us run the inference. Let me show you the pods. So it's only 2 pods, senior architect agent and a software agent. So let me do an inference. So there will be a lot of communications going on. I'll not show you the logs of each of this agent. So let me just refresh it. Yes, the first communication has come. This is from the software agent. So let's not worry about this. Initial overall architecture. So it has a data store layer, user distributed key. It has started giving some content. So before that, let me just show you the what is that I'm asking. So let me go to agent registration. As it might take time, right? So several communications will debate will go on for all the components, so it will take time for reflecting all the results, but we can always keep refreshing this so that we will get the timeline. It's like this is the initial one, then this will go to the our senior architect agent. It will break down that, so it will again talk to the software agent by giving one by one component. So this communication is going on now. So right now this is round 2, round 3, and again if I refresh it, so round 4, round 5. So this is a series, it is an incremental round count is going on, but this will take care of controlling the when to break the, for per component, when to break the loop. This senior architect agent will take care. So let me show you the what input inference request I've asked. So just refresh it by the time it loads. So wherever we are seeing these 3 items, it means it has broken down those, it has done with the one particular component. So that's what we need to identify the pattern. Yes, the inference request. So what I'm asking is design a highly scalable, fault tolerant, high performance, distributed frame sharing stack for short-lived frames of RTSP stream processing at scale. These are fast incoming frames with a short life cycle that will be discarded, deleted once processed. So from RTSP stream we are getting frames. It has to stay for a short lifespan. So once it is usage is done, we need to discard it. So basically we require a fast IO kind of a requirement is there. Requirement scope: the solution should focus exclusively on frame sharing, ignore stream decoding, ingestion logic. So we are just asking it to ignore all those decoding pipeline and all, and anything else. Focus on the requirement: fast frame storage for short life cycle, followed by immediate access and deletion. Concurrent stream: support 10,000 plus live RTSP streams simultaneously. Frame rate: handling 5 to 25 frames per second per stream. JPEG encoded frames will come, so it has to store the JPEG encoded streams. Image size: so each JPEG image can vary from 300 KB to 2 MB when pushed to the stack. High throughput: provide ultra fast read and write access for real time processing. Distributed architecture: the stack must scale across multiple nodes to leverage all available hardware in the cluster. These are very important instructions that we are giving. Consumer model: support distributed AI models that fetch frames for inference and issue deletion command once processing is complete. Resilience: ensure the system is fault tolerant and maintains performance under heavy load as well, workload. So open source: we want all the components finalized, chosen for the architecture must be available as a open source. So we are asking for open source requirement as well. So let us see the his dashboard now. Now it is in the round 13, so it will take a lot of time maybe. So first let us see. So it is saying about a round 1 initial overall architecture plan. The first component is data store layer. Use a distributed key value store like Cassandra or Redis to provide a fast read and write access and support for a high throughput operations. This layer ensures scalability and fault tolerance. Frame storage layer: distributed object store such as Mini or S3 to store the JPEG frames. This layer handles the storage of a large frames up to 2 MB and provides a quick access for a processing. So we have a Cassandra Redis for a data store layer and frame storage layer, and a frame caching layer. Again it is saying Redis or a mem cached for a caching, because once the image is accessed, again if you want to access it, you can use this kind of a layer. A processing layer: distributed process like Apache Flink and Apache Spark, which we have not asked for this, but it is giving that. Distributed framework layer: Kubernetes or a Docker to manage containerized processing units. Consumer layer that allows the distributed AI model to fetch frames and issue deletion command. And a fault tolerance and resilient layer: eventually consistent and retries. Monitoring and logging layer. So all these are the components, 8 components it has given. But again we can ask for one more round of check from the, again we can add one more signature maybe. Since it has proposed the architecture, we can make sure that senior software agent again discusses on this all the components, whether it is required or not. That kind of signature also we can add maybe in the agent, the senior software agent, so that it will also fine tune the instead of 8 component, maybe it can be done with 5 component. So certain things may not be needed, so it can do that check as well. But right now I'm not doing that. I'm directly parsing the output of the software agent and breaking it down to each component, and then I'm discussing on the each component, not on the overall architecture. That also can be incorporated. So the senior software agent, it evaluates each and every layer, each and every component. So iteration 0, score 75, needs refinement because the first component it has data store layer. Iteration 0 needs refinement, raising the data store layer is a critical component for the frame sharing stack as it directly impacts performance, scalability, and fault tolerance. The proposed solution uses a distributed key value like Cassandra and Redis. Why convinced? 80%. So scalability, distributed key value store like Cassandra and Redis can scale horizontally across multiple nodes, making it suitable for handling 1000 labs, high throughput, fault tolerance, open source. Why not 20 latency? While these systems are scalable, they may introduce a latency due to network communication data consistency mechanism. This could affect a real time. So data consistency, complexity. So this is the reasoning details from it. So right now we are using the model that both are using is a very Pen 3 1.7b model. So if you are using a powerful models, maybe they will give a better content, or a better, they will convince you better. So now this is the evaluation phase, and once evaluation is done, before sending it to next agent, which is the ultimate software agent, it has to dump the this value as well, this content, critic of previous proposals. So message to software agent, critic. So this is what the content it is going to the software agent. So the same content that it has got, right? So it is sending, before sending it will just put that to his dashboard. So that's why it is coming here. So here data store layer, so the system is designed handling, so it is bringing some raft paxos, so it is saying something. So let us see the next one. So now the score is 80, needs refinement, reasoning. The data store layer is promising component for the requirement. So it is again, so your intervention, so we don't require any intervention here. So basically it is weakness data store, again it is giving certain details related to some other new component. So let us see what is going on in the third round. So distributed fault tolerance, data store layer data, again it is saying few details, again it is bringing some these details, rocks, db, raft. So since this communications will pass on, right, so they will bring new components here and there, but at the end it has to settle for one particular component. So let us see that particular message where it is settling down. So yeah, still the score is 80 only, even at the end only, right? So it is at 80 only, it has not crossed that 90-95 that our requirement is, but it will stick to that and it will finalize that. So we can maybe ask it for more if in case we increase this, right, it might better maybe, or else if you use a better model, it can give a better details, or latest recent models we can also give better details maybe. What if storage layer fails during the peak load? What if network latency? So yes, that's what basically it is finalizing it. It is not going for some feedback. What if the self object? It has some again feedbacks to it, but that component is finalized now as that component is finalized. So next it is going for a frame storage layer, description, distributed fault tolerant, high performance. Okay, maximum image size, Apache Kafka, Cassandra, Apache Kafka, application factor. So it is giving certain details related to what should be the CPUs, GPUs, storage requirements, network, all those network related, the computation, it is just printing it here. So now the second component is going on in the discussion. So this way it will keep on going, and wherever you are seeing 3, it means like it's done with that component and it is moving on to the next component. So let us see the final, whether it has synthesized the final one or not. So yeah, the final one is done for all, like around 23. So we have 8 component and 8 into 3, 24. So around 25, right now it's 25th round. So the final synthesis will happen here. So final architecture plan, the data store layer serves as a foundational component, 1000 plus live streams. So this is the 10 GB network. This much is the frame throughput. Input disk IO is required. So that details it is synthesizing 16 GB RAM, 32 vCPU per node. So it's a node details also it is providing here. Frame storage layer, RAID details, because it's a key value Cassandra with custom garbage collection algorithm. So it is talking about Cassandra, not no Minayo is required. I mean Minayo or Cassandra it was saying, now it is finalized to Cassandra. Frame caching layer, hybrid memory disk based caching. So LRU it is using Redis cluster. Redis is finalized here. So similarly it has finalized all the components that is required. So this is what the component the critic reflection is. So you can better this by giving some more examples. So these are the finalized content from the senior software architect. So yes, I mean we can always better this. We can plug in the better model, or we can add some more. We can fine tune the system messages for this this agent, the evaluation agent as well. We can always better that. So now the output is done. We can I'll clean up all the pending all the because it's in his side, right? So they, whenever you do a refresh, it will still coming. So let me just delete all, so that all the pending the status pending will be cleaned as a completed. So now I don't have anything. So even if you refresh, you will not get anything because all are deleted. So to stop the pods, we can run this. So all the pods will be like the agents will be removed. And basically critic reflection pattern ensures the output meet a high bar or a technical excellence. By automating the review fix loop, you can achieve the complex technical goals with a far greater reliability than a single pass generation. So we have seen that if you ask the same question again and again to the agent, so it will better its output. So that's what we have certain papers describing it. So critic reflection, where you are talking the agent with the same just by giving a feedback to it, it will better its component details. So this is the pattern that we need to use whenever you require a debate or debate architecture. So that's it about this video. So hope you like it, and if you like it, don't forget to subscribe and support us. Thank you.